Okay, problems 5 and 6 on set B this week. This is, I want to read the whole thing to you. You can see it. This is just a straightforward hypothesis test for the difference of two means. We have these two drugs, trying to see if the new drug does better than the old drug. So list the conditions. Two independent simple random samples. Both samples are more than 30. Both populations more than 10 times the sample. Population standard deviations are unknown, hence the t-test. The null hypothesis is the mean decrease of the new drug is equal to the mean decrease of the old drug, or mean 1 equals mean 2. The alternate is the first mean is better than the second mean, because that's what we're trying to test, that the drug's doing better. Use a pair, found a critical value. It's a t star, so I did inverse t, 95% to the left. 98 degrees of freedom, I believe it was 50 of each, 50 minus 1, 50 minus 1, 49 plus 49. I got a test statistic, and then I just threw in the numbers, right, the data. Test statistic of 3.92, basically a p-value of 0, which means we're going to reject the null, which means there's evidence that the mean decrease of the new drug is greater than the mean decrease of the old drug. If I was a gambling man, if I had to bet, I'm pretty sure you're going to see some sort of a full all-out hypothesis test. We'll talk more about that as we get a little bit closer, but I'm sure we'll see one of these on the exam. And then the last problem is number 6. This is the problem with the land area and the extinction, that sort of thing. So they had islands and how many, the size of the islands and how many species were extinct. And the first one, they're trying to show if the larger islands were more apt to keep the animals. And so I didn't write this all up because we just did a test, but this should have been a full test. Basically, it's a 2 proportion Z test. The main conditions are all the samples are bigger than 10, N1P1. The proportion of the extinct on the small islands is equal to the proportion of the big islands. The alternate is it's worse on the smaller island than the bigger islands, because that's what we're trying to show. And I got a test statistic based on their data of 3.8 with a p-value of 0, basically, again, so we reject the null. So there is evidence that the extinction rate is larger on the smaller island than it is on the big island. And they asked me to do a confidence interval, because they said, well, let's just not separate between big and small. Let's see if there's a difference as we get bigger, as we get smaller. So all this data, this is a really good example of not using your calculator to do a problem where you have to remember the formula, right? And they give you all the data right in the chart. So the slope was the negative 0.053. The critical value was 2.2. Degrees of freedom was 11 on this. So I just did an inverse t for that. And then this is the standard error of the slope, which is hiding in the chart. Where is it? There it is, 0.00618. So my interval became negative 0.053 plus or minus 0.0136. They wanted me to interpret that. So there's two things. You've got to interpret the interval, the whole idea of the 95% sure. But also there's a slope to interpret, right? Because this is a slope. So we're 95% sure that the average number of extinct species decreases, hence the negative, from between negative 0.04 and negative 0.06. I might have added those up wrong. Check that. With each increase in 1 unit of the land area. So the land area goes up by 1, and the extinction rate goes down a little bit. The last two questions kind of put it all together. The first question says in part A, the scientists assume the probability becoming extinct is the same for each of the large islands. Similarly, the scientists assume the probability is the same for the small answers. Do you think that's an assumption? And no. I should have put here because 0 is not in the interval also, right? So because 0 not in interval. So it's not the same for all large ones or all small ones. We would probably see 0 in that interval if that was the case. So it is changing. And then the last question is, what should we do? Should we build a large preserve or a small preserve? Everything's telling us to build a large preserve, right? This test is telling us to build a large preserve. And the interval is telling us to preserve a large preserve also, because it's going down as the area goes up. So yep, that's it on problem number 6.